So after Chichi-Weber reaction, we have seen Chichi-Weber reaction. So after that, we will go for the next slide. Here also the same reactivity pattern as we have discussed already. This reactivity pattern, nucleophilic substitution reaction. Now displacement of halogen atoms. So that's when we have nucleophilic substitution. So this is a little bit easy displacement of halogen atoms. So here we have taken 2-chloro quinoline and 3-chloro isoquinoline. So 2-chloro isoquinoline on treatment with the strong base sodium methoxide, sorry, and ethanol. So ethoxide group is getting attached or is getting displaced over here by chlorine. So how the displacement occurs here, they have shown the mechanism and how the aromaticity again regained after that one. So with both things, with quinoline isoquinoline, the same reaction I have explained over here. So like pyridine here, the same mechanism, displacement reaction. This with bromo, to bromo quinoline on treatment with ammonia, heat, elimination of HBr. We have to replace this bromine with NH2 group. So in this way, we can get 2-amino quinoline. These are the nucleophilic displacement reactions. So next one, the riser synthesis, which is one of the famous synthesis, riser synthesis. So in alkylation as well as second position alkylation we can do through the riser reaction. Okay, so these are the riser reactions. So quinoline on treatment with acyl chloride COCl. So first one, the acylation occurs at nitrogen atom. Okay, so in acylation occurs created positive charge. Then potassium cyanide we have used, so we wanted to induce cyanide group over here. Okay, so the cyanide group second nucleophile is getting attacked. This one is electrophilic. This one lone pair which is present on nitrogen atom, that one attacks on the carbonyl carbon. Chlorine group is getting eliminated, and in that way acyl group is getting attached to the nitrogen atom. After that we have to use potassium cyanide. So Cn minus is getting attacked at the second position of the quinolinium ion. So cyanide group getting attached at the second position, shifting the C double bond N on the nitrogen atom. Okay, so the synthesize this intermediate is on treatment with base methyl iodide. So methyl iodide, we are going to replace this cyanide with methyl group. So attack of the methyl iodide. Okay, base in presence of base, we can generate the methyl Me minus I plus. So methyl minus is getting attacked at this position. That means replacement of CH bond by the methyl group. And finally the on treatment of sodium hydroxide, we can do the various rearrangements on this acyl group, and finally we can eliminate this cyanide Cn minus ion as well as this bulky group, and then that way we can get the methyl group getting attached at the second position. So the proton adjacent to the cyano group is extremely acidic. This proton is highly acidic. That's why we can do such types of reactions. The reaction works best with highly reactive alkyl halides. This is the riser reaction. It comes under the nucleophilic substitution reaction. Then carbon nucleophile. You know carbon which acts as a nucleophile. So lithiated compound or Grignard, those acts as a not Grignard but lithiated compound. We can say that those there is a negative charge on this carbon atom. So it acts as a nucleophile, lithium plus and C6H4 minus. So this one attacks at the second position. After and this lone pair is getting utilized to abstract lithium plus. Okay, so N lithium is there is a formation of N lithium bond, and then C minus C6H4 minus is getting attacked at the second position. So this type of intermediate we got on hydrolysis. We can lithium hydroxide is getting eliminated and NH bond is created over here, and which is on oxidation. We have to remove this both hydrogen, that is the these hydrogens is getting removed. That is nothing but the this compound is undergoes the oxidation reaction. Once this two hydrogens getting eliminated, then we can regain its aromaticity of the quinoline. This is the carbon nucleophile and how we have to do the reaction. So how the electrophilic reactions, substitution reactions, how they are different from the nucleophiles, that I wanted to show with the help of these slides. Again, quaternization of nitrogen atoms. So again, we have seen this reaction actually. Arsenic fluoride is getting electrolytic substitution reaction occurs at nitrogen atom in CN minus. This reaction we have seen already. Cyanide. This hydrogen is highly acidic. Okay, which is present at the carbon which possesses cyano group. So this hydrogen is highly acidic, so we can take benefit of this acidic hydrogen atom, and we can replace this CH with we can oxidize this one CN oxidize to COH, and in that way we can get the final product. Metallation of benzylic position. So metallation, first one, deprotonation at benzylic position, that gives inaminate anion, and C4 is more susceptible than C2 for quinoline. C1 is it as facile. So second position, methyl group is present, and we have to replace this methyl group with um, this type of, that's methyl, that means one of the hydrogen of the CH3. We have to abstract this hydrogen by a strong base sodium methoxide, and once we generated this carbanion, we can attack on this 1,3 diketone or 1,2 diketone compound. So in that way we can extend the cyclic open chain compounds. So this is also metallation at the benzylic position. Now next one, we are going to switch for the synthesis of the quinoline. So first one is the one of the most famous synthesis, scrap synthesis of quinoline. So for that synthesis we need glycerin as a starting material and aniline, and we have to react these two components in presence of concentrated H2SO4, and finally at last stage we need oxidizing reagent. So here we are going to use nitrobenzene. So nitrobenzene acts as a both solvent as well as oxidizing reagent, and we can synthesize quinoline in this way. So pay attention, this benzene ring and nitrogen comes from this aniline, and remaining three carbon atoms which will come from the glycerin. Okay, glycerol, you can say that one comes from the glycerol. So here I have shown 1, 2, 3 carbon atoms comes from the glycerol, and the remaining benzene ring and nitrogen atom comes from the aniline. So scrap synthesis is a chemical reaction used to synthesize quinolines. It is named after the Czech chemist Zdenko Hans Scrap 1950 to 1910. In the archetypal scrap reaction, aniline is heated with sulfuric acid. Okay, so we are going to heat aniline in presence of sulfuric acid, glycerol, and an oxidizing agent, nitrobenzene, such as nitrobenzene, to yield the quinoline. We'll see now the step by step what is the mechanism of the scrap synthesis. So first one, glycerin or glycerol. This one is glycerol. So glycerol we have to treat with the H2SO4. So acidic treatment of this glycerol having 3 hydroxyl group and 2 methylene group and 1 CH group. So on treatment with glycerol, OH groups on treatment with the acidic condition. Protonation of OH group occurs to form OH2. As we know, once OH2 is forming, that works as a best leaving group. So it eliminates that this one of the OH group is eliminated in form of water molecule, resulting in the formation of the acrolein. We have to synthesize this carbon-carbon double bond. Acrylaldehyde we have to synthesize. Carbon-carbon double bond containing aldehyde. Okay, so alpha allylic aldehyde group we have to synthesize from the glycerol. So one hydroxyl group we have eliminated in form of water molecule. So there is generation of carbocation. So we have to again abstraction of water molecule, again abstract proton to generate this carbon-carbon double bond. This structure on tautomerism shows the aldehyde, and on further different rearrangements. Okay, on treatment with the same, we have in our flask concentrated H2SO4, and in situ also we do have water molecules also in our reaction mixture. So both they works one by one, concentrated sulfuric acid or acidic moiety H3O plus, as well as water molecule. Okay, so both these molecule works as simultaneously to afford our desired product acrolein or acryl aldehyde. Okay, so in that way treatment of the glycerol with in acidic condition, it affords finally this acrylaldehyde. And now we are going to utilize this acrylaldehyde to react with the aniline. Okay, so here I have taken acrolein. Okay, alpha beta unsaturated carbonyl alpha beta unsaturated aldehyde, and we have to react with the aniline. Okay, so now lone pair which is present on the nitrogen atom, this is 1,4 addition again. So it adds via 1,4 addition to the carbon carbon double bond alpha beta unsaturated carbonyl carbon, and generation of positive charge, again negative charge generated on oxygen atom on